Right. Vertex form. Today's lecture is going to be pretty short. I'm going to show you a different form for quadratic equations. So typically when we see quadratic equations, we see them written like this. Y equals ax squared plus bx plus c. We're very used to that. But if you think about it, that form is not really very useful, right? It's not like, if you think of slope-intercept form for graphing a line, the form actually is telling us the slope and the intercept, right? This form doesn't tell us anything really about the quadratic. We have a bunch of formulas that help us to figure out where the vertex is, right? Negative b over 2a. Help us figure out the roots, right? Which is like the whole quadratic formula that you guys learned. Negative b plus or minus the square root of b squared minus 4ac over 2a, all of that, right? But that's pretty complicated. It's not like just simply, a means this, and b means this, and c means this. So there is a form of the quadratic equation that has meaningful constant terms. And it looks like this. Y equals a parentheses x minus h squared plus k. Now this is kind of ugly, right? It's like got these parentheses, and not only does it have parentheses, it has a coefficient in front of the parentheses, and everything in the parentheses is squared. So it's not very fun to work with, really. But the beautiful thing about this is h comma k is the vertex. And if you think about graphing a quadratic equation, all you really need is the vertex and a. So this a is the same as this a. These two a's are the same thing. And so if I were to give you a quadratic equation in vertex form, you could graph it much quicker than you can graph a quadratic in this form. Because you immediately know the vertex, hk, and you immediately know, just like you did before, how wide or narrow that quadratic is going to be. Yeah?
If h was, say, 6, would the minus sign before it count as h, so it would be
Right.
negative 6?
Yeah, so let's look at an example of this. And the question today is simply going to be, what is the vertex? So if I gave you this equation, y equals 2x minus 10 squared plus 5, what is the vertex of that?
Negative 2.
And the answer is 10, comma 5. So this is kind of like point slope, right? We have a negative in front of our h. So when we look at this number, we're taking like the negative of this number as our x coordinate in the vertex. So minus 10, that means that the x coordinate is 10. And it sort of makes sense in that 10 minus 10 is what's going to give you 0 in these parentheses. So, and then you can kind of see where the 5 comes from. If this is all 0, then y simply equals 0 plus 5. So y would be 5 there. So what if I give you one like this? Y equals 3x plus 4 squared plus 3. What is the vertex of this equation?
Negative 4 comma 3.
Yeah, negative 4, positive 3. What if I gave you one like this? Y equals x plus 1 squared. What is the vertex there? Yeah, -1 comma 0. So let's just take 1 second to kind of prove that this is true. If I converted this into the regular form, right, just by expanding this, I'd have y equals x squared plus 2x plus 1. Right? This is the same thing as this. And the way that we would find the vertex here is what? What's our formula that we use to find the vertex in this form? Yeah. So negative b over 2a would be -2 over 2. Right? Which would be -1. That's our x coordinate. Oh look, it's the same. And then we'd find our y in this case by going y equals -1 squared, which is 1, plus 2 times -1, plus 1. So we really have 2 minus 2, y would be 0. So we do get the same vertex by doing that we got here. But look at how many more steps that took to get it from this equation versus from this equation.
Is there a way to turn that, like the quadratic form, into the vertex form?
Yeah, and we'll talk about that probably tomorrow or the next day. Yeah. For now, I just want you to learn what this formula looks like. So this is very useful. It's really easy to get the vertex, and then from there it could be really easy to graph that as well. And that's it. That's vertex form. Any questions about it? Oops, I'm totally off the